Good evening. Welcome to the Village. Um, the Village is an interactive webinar series run by educators for educators. Tonight, it is my privilege and pleasure to introduce my colleague, Sarah Bent, who is the Assistant Director of Mathematics Leadership Programs at Mount Holyoke College. She also directs the Master of Arts in Teaching Mathematics program. And prior to joining us at Mount Holyoke College, she was an adjunct at Westfield State, as well as she taught grade 3 and 4 students at Chesterfield. Tonight, we're going to have a really interactive session. And so we usually follow this welcome with a set of instructions on what to do with your video and your chat. But Sarah, I believe, will be telling you what to do this evening. So without further ado, I'd like to welcome Sarah Bent, who's going to be talking to you about using mathematical routines to engage all learners. Sarah?
Thanks, Bev. Can you hear me okay?
Hi.
Hi, thank you. And thank you everyone for coming. So as Bev said, this is going to be a really interactive session. So what I would like you to do is turn on your camera. But before you do that, just make sure that you remember that we can all see each other once your camera is on. So make sure where you are and what you're doing that you're aware of that. So down at the bottom left-hand corner of your screen, if you could turn on your camera where it says, where the video icon is, so that we can all see each other. This will just help us as we work together. Also, one more thing that would be really helpful, if you could rename yourself. So find your box along the top of the screen, and there are 3 blue dots, or a little blue box with 3 white dots. If you click that, and then there's an option to rename. If you rename yourself, leave your name there that you want us to call you, but then add on the grade level or grade levels that you work with. That way, when we're in small groups, you have that information as you're interacting with each other. All right, I'm going to share my screen so we can get started. So we're actually going to jump right in. As Bev said, this is super interactive, so feel free to just type right into the chat box or unmute your mic and share aloud as we go through. We're going to engage in these routines for ourselves. So the first one is called Which One Doesn't Belong? So I want you to take a peek at this image and think about, to you, which of these doesn't belong? Again, feel free to type it in the chat box or unmute yourself. I see some comments in the chat. So one thing is, because this is being recorded, the chat won't be recorded. So if somebody would be willing to share verbally which one doesn't belong to you, that way that will be caught on the recording.
I said the pentagon doesn't belong, and my reason is because it has 5 sides instead of 4.
Okay, nice. Who was thinking about a different one? So does everybody agree?
I said the one with different color because the other ones are white and that one is gray.
Nice. The one in the top right?
Right.
Yeah, nice.
You could also say the top left because the sides are not equal.
When you say the sides are not equal, what do you mean by that?
The length of the sides are not equal, but on all other 3, the lengths are equal.
Okay, nice. And I see someone has reasoning for the bottom left, that it's turned on a different axis. So as you may have noticed with this routine, there's actually a justification for why each of them doesn't belong. And there's actually more than one reason. So just because we found one doesn't mean that we can't continue to think about others, but we're gonna try another one now. So out of these, which one doesn't belong?
73, because it's not a square number.
Okay.
121 because it's, well, I guess the other ones are, I was gonna say it's 3 digits, but then the other one's only 1 digit. Well, it's greater than 100, I'll say.
Okay, nice.
I would say 9 because it's the only number that has like just 1 digit.
Uh-huh. I see Abby says 16 is even. So we found one reason for each. Can we find another reason for any of these for why they don't belong?
Is 121 a square number?
Yes, it's
Okay.
11 squared.
Yeah, so 73 is not a square number, but the other 3 are.
Nice. I've heard people say before that 16 doesn't have like a 3-ness to it. So 121 and 9 are divisible by 3. Or no, actually 121, the digits add to 3. 9 is divisible by 3. 73 has a 3 in it, but 16 feels like it doesn't have a 3-ness to it.
The digits of 121 don't add to 3.
Oh, I'm sorry. You're right. I'm sorry. I meant 2 of the digits of 121 adding to 3. Thank you. But it feels like there's a 3 in there. We're going to try one more. So if you go to estimation, if you go to which one doesn't belong, if you go to their website, they have these 3 categories of puzzles. So they have shapes, which we did, numbers, which we just did, and then they also have graphs and equations. So we're not actually going to do this one because I know you can't see it very well, but this is just another category that I wanted to show you. So these all come from this website, which one doesn't belong. So it's wodb.ca is the website. And Mary Barassa is the one who runs the website. And it's actually mostly people submitting these puzzles to the website. Also, Christopher Danielson has a book, Which One Doesn't Belong, that's full of these puzzles. But I want to talk about, so there are 3 themes that we're going to be discussing during this session. And the first one is access. So just thinking about each of these routines that we engage in what ways can it support and challenge learners? So thinking about like, in what ways does it have a low floor and a high ceiling? So feel free to unmute yourself or type into the chat what you're thinking about this.
I think because there are like multi-entry answers for them, they could feel like all the students with different levels, like a differentiation between the students.
Nice.
The one thing I've noticed is there's really no wrong answer as long as you have a reason for why. So sometimes students will come up with something that's not necessarily mathematical, but it does support their reasoning.
Yeah, nice.
I would also add that just having to justify your answer is like one of the math practices involved.
Yeah, absolutely. So another theme that we're going to be talking about is flexibility. So how could you use this with your grade level or in different content areas?
For early childhood, it's great because you can do shapes, which is one of the standards, but you can also do it with numbers. You can do it with measurement, which is another standard. So you can make it fit almost any number of math standards, I would imagine.
And if you're on Twitter, so they have this hashtag is WODB. You can actually search that hashtag and it will pull up all different kinds of people doing which one doesn't belong with flowers in their garden or with their breakfast or all different kinds of things. So it's even more, there's tons of resources on the website, but there are even more if you just search that hashtag on Twitter. So the third theme is, Baini mentioned the mathematical practices. So what connections do you see when students are engaging in this activity? What standards of mathematical practice are they using?
Number 3.
Can you say more?
So they have to have an argument for which one they decided didn't belong. And then the critique the reasoning, sometimes kids get into like a little debate over whether their answer is right or someone else's is right.
Yeah. See, attend to precision in the chat box. So precision in our language even, right? Thinking about using precise language.
So practices 7 and 8, I get a little confused on, to be honest. Like structure and repeated reasoning, I'm not sure, but I know that it's one of those. Just in looking for like a rule that fits.
Right, exactly.
What about number 1? Make sense of problem. And I think, yeah, it needs persevere to solve them.
Yeah, absolutely. Especially when you get to that point where you have a reason for 3 of them and you're trying to find that reason why the 4th one doesn't belong, right? And that can be really tricky. So we're going to sort of repeat this format with a few other routines. So we'll engage in it ourselves and then we'll reflect on these themes. So the next one I want to share with you is Estimation 180. So this is Andrew Stadell's website. And it again has a range of different activities. So we're going to try a few out ourselves and then we'll chat a little bit. So how many pieces of candy corn are in the cup? So before you think about how many pieces of candy corn you think are in this cup, I want you to first think about what would be a too low answer.
4,
4, yeah, why 4?
because I can see 4 already.
Okay, nice. So can we be braver than 4? Can we find a too low answer that's higher than 4?
8,
Mm-hmm.
I think. Yeah, I can see 8.
Okay. What would be too high?
30.
30 would be too high?
20.
So I want you now to think about how many pieces of candy corn you think are in the cup, and you have to have a reason. So it can't just be that you made a wild guess, but you have to have reasoning to justify it.
So I'm thinking in 4s, like in going with that 4s. It does seem like just from this view that maybe each, like there could be either layers of 4 or like clusters of 4. And it seems like there might be 4 clusters of 4, which would be 16, and then maybe a couple more. So my estimate would be 18.
Okay, nice.
My estimate would be 15 because I can see it as like 2 layers of almost 7 in each layer and 1 which is out of the cup. I don't know whether you should count that or not, but yeah, 15.
Okay. Is anyone thinking something that feels a little bit different than the 2 estimates we've heard so far? $17. So this website is one that you can actually use with your students. You can pull it up and you can type right in. So it goes right to a Google form. So you can type in their too low, too high, their estimates, and then their reasoning. And it does prompt you to give a reason. And then if you even wanted, you could look at the all of the estimates. So you can open up everybody's estimates, but I don't recommend doing that in front of students because people can write whatever they want in there. And then, you might see inappropriate names or inappropriate reasoning. But so I wouldn't recommend doing that, although they always want to do that, of course. But there's always a reveal in Estimation 180. So sometimes it's a picture and sometimes it's a video. So I'll show you this one. See some head nods. How'd you do? So for those of you who were maybe a little bit off, what did you learn? Everybody feel spot on with this one?
I was a little bit less. I think the physical shape, like they're able to kind of tuck into each other. They're able to kind of like overlap within the middle of it. So you kind of lose track there.
Yeah. So this one actually builds. Not all of the activities in Estimation 180 build, but this is one that does. So once we've done that one, now we can look at this one. So what would be too low of an answer here for how many are in the bag?
$19 seems like an easy low.
Definitely 19, right? So can we be braver than 19? 100? What would be too high?
1,000, or maybe there are 1,000. I don't know.
So what's the benefit of asking students to think about too low and too high?
The reasonability of their answer. When they do get to the end, if they have something close to 19, then they know they've gone wrong.
So sort of like setting up that range of what's reasonable. Yeah, nice.
Giving like all the students the opportunity to participate, because being too low or being too high, it can be like any number that would be like engaging for all the students.
Yeah, absolutely. And you see, so anyone can participate, and you see students that that will say 0 for what's too low, and they love to say 0, and they love to say the largest number they can think of for what's too high, right? But they're engaged and they're thinking about it, and then you can prompt them to be braver. But let's continue now. So what do you think about for how many pieces of candy corn are in this bag?
I was thinking maybe there's like 3 cups in there. And so a quarter cup is 20. So I don't know, maybe around like 250 or 300. No, that's just what I was thinking based off of how the bag looks compared to the quarter cup.
Uh-huh. What are other people thinking?
So I'm using some like spatial reasoning where I'm kind of visualizing that there's 5 of those cups across and then 2 deep. And then maybe 3 high. I don't know, 2 or 3 high. So I don't have a number, but that's how I'm thinking about it.
Sort of using that same idea of layers that people were talking about with the last one.
There's also probably a lot of air in the top of the bag, like there usually is, right?
Yeah, definitely, right? So we'll take a peek at this one, and then I see there's a question, so let's chat about that question after. So this one doesn't have a video reveal. We can just see from the nutrition label that 893 pieces of candy corn. And this one, again, like there are other options that you can use, like how many scoops would it take to fill the jar? So this is one that, like I said, builds and has other related lessons. So I saw there was a question about visual impairment, so let's chat about that. What do you think about how we could adapt this for students with visual impairments?
I wonder if you could do some sort of tactile activity. So the issue is that you would then have to be able, for the candy corn one, you'd bring in the candy corn
Yeah,
and maybe allow students to either touch or, I mean, depends, I guess, on the visual impairment perhaps, but just being able to have the actual object and the quantity in front of them to be able to touch or perceive in another way.
yeah.
I was also thinking if it's something like candy corn, it could be like an auditory thing where they hear it like plunk into the bucket.
Yeah,
And then
nice.
you could almost even like cover it up for everyone else and just have everyone listen to the sound.
Uh-huh. Nice. Yeah, so this is something, one of the things that I love about Estimation 180 is we can look at it on the website, or we can also have it in our classroom. Like we can get candy corn, or we can get, there are ones with almonds or all different things. Like we can do that in our classroom, so we can let kids touch it or listen to it. Those are great ideas. I just wanted to show you one more. We're not going to do this one, but I just want to show you some other versions. So they're not all about like how many in, but some of them are like, how long is this song? So we can see this piece of it. We can see how long that piece is, and then thinking about how long is the whole song. So we have lots of different types of estimation activities on this website. And another thing is they have a resource for, so you can do this orally with students, or you can even have them do it on paper where they're thinking about and recording they're too low, they're too high, they're reasoning. And then also on a number line, they're putting in they're too low, they're too high, and their just right estimate. So they have to think about, where would my just right estimate go in terms of my too low and my too high? Is it right in the middle? Is it not right in the middle? And they have to think about that. So we're going to return to our 3 reflection questions. So in what ways does this support and challenge all students? So we talked a little bit about visual impairments.
I'm thinking back to an example where we did something like this with graham crackers, and somehow there was an expertise, like someone loves graham crackers, and so they're like, I know for a fact. So there is part of making it real, and like a context known makes someone who may not always be a math expert an expert in a certain case.
Yeah, nice.
I was going to kind of add on to what I was thinking about with fractions before. I find that if actually really in any part of math, but the students, the biggest problem is they can't estimate and know whether what they're doing is reasonable or not, whether they're solving straight calculations or some complex word problem. If they get an answer that's totally not in the ballpark, they don't often even realize that. So this kind of builds that understanding that you should check for reasonableness.
Yeah, definitely. Yeah, that's complicated for students to understand, like that there's a difference between, like, you can be incorrect but still reasonable, and that's challenging for them to understand. Absolutely. How about the flexibility? So how could we use this routine and adapt the content to different age groups and different content areas of math?
Hi, Sarah. Came in a little late, but
Sam,
hi there. I noticed that you were working on that task that and as I came in, you guys were talking about layers, and that is perfect for the secondary idea of um, you know finding the volume of any prism or even cylinders, as is the case here. And then sort of backing it up, I think estimation is a good activity really for like students of all ages. I particularly think of young kids starting to get an idea of estimating and how important it is to just have a notion of where the answer is.
yeah, nice. So how about the mathematical practices? What connections do we see with this routine?
I think number 3 again, because for the same reason as the first one, they have to justify their thinking.
I was thinking about number 5. I don't know whether it's related or not, but they need some strategy to actually solve the problem. And for the last, actually previous question, I was thinking about that it was these kind of activities are also really, good for all levels of the students because they can still use the different strategies for the same problem. Like for the previous one, they can use multiplication, or some of them can even count by one by one. So it would fit like all the students with
Yeah.
different levels.
That's a great point. So lots of entry points for everyone. The next routine that we're going to try, we're going to break off into small groups. So first we're going to chat a little bit about it, and then I'm going to send you off into some groups to work together. So this is inspired by Kristen Gray's. She's been blogging a lot about what are called numberless word problems. So this is an example. This is her example that I wanted us to try together. So Webster has boxes of granola bars to share with his class. So we start by just sharing this context and then asking, what do you notice and what do you wonder? So I'm going to ask you, what do you notice and what do you wonder? Again, feel free to type it in the chat or share aloud. Okay, noticing the granola bars come in boxes. How many students are there? How many granola bars per box? When we do this with students, we always hear what flavor granola bars are they, of course, right? Our students are always curious about that. So then we ask, well, what more would you want to know? We want to know how many students. We want to know, is everyone getting the same amount? How many students? So if we knew the answers to those questions and the questions that you raised earlier, what could we answer? If we had that information, what questions could we answer? How many granola bars each student would get? Yeah.
How many would be left over as well?
Nice. So this is a 3rd grade context, but it doesn't have to be, right? So what if we thought about this even at other levels? What questions could we answer if we had more information? Well, I'm going to let you think on that. So what I want you to do is, oh, cost. I see cost in the chat box. I want you to add your own numbers. and adapt this context. So we still have Webster with boxes of granola bars and sharing with the class, but you get to add your own information and adapt it how you wish for whatever grade level or even for you as an adult learner. So I want you to take a few minutes to just have some private think time and jot your notes, and then you're going to chat with people in a small group. So hold on, let me stop my screen share. Whoops. So go ahead and take a few minutes privately. I need to get myself out of this. And then what you're going to do, you're going to get an invitation to join a small breakout group. So you're going to join that group when you see your invitation on your screen. So take a minute, go ahead and mute your mic if you're not already muted, and just work on this on your own. Okay, you should have an invitation now on your screen. So Bev, I sent you one too, but you don't have to go there if you want to stay in the main meeting room. Bev and Lauren. All right, it looks like everyone's back. So I'm really curious to hear about the context. So what did you write to finish this situation?
Our group talked about how if you have all of the information, you know, how much each box costs, how many students are in the class, if whether or not each child will get the same amount, how many, did I already say it? How many granolas are in each box, all of that, that you could still be asking for different information. So I think it was Julia that pointed out that you could be asking for any of the four kind of what are those called? Multiplication, division,
The operations? Yeah.
and addition. So that you'd need to be really specific about the question that you asked. So for early childhood, we would write something like Webster has granola bars to give out to his class. There are 4 granolas in each box. He has 5 boxes. Each child will get the same amount. There's 20 kids in the class. You know, just be really clear about it, but you could become more complicated if you wanted to ramp it up for upper elementary or secondary.
Yeah, nice. So who has another example that's perhaps, as Molly said, more complicated than the example that she gave?
I was thinking about having this problem as a fraction problem. Like, for example, we had 7 bars and we want to divide it like equally to 18 students to practice dividing the bars and distribute them equally to students.
So you're saying having fewer bars than there are students even, so they have to break them up.
Yes.
Yeah, nice.
I have one. What if you said how many boxes there are and how many bars in each box, and you say how many he has remaining, and ask to give a reasonable number of students in the class, and that would involve both subtraction and division.
Yeah, nice. So you're now saying what we want left over, maybe what Webster wants to bring home, right?
Mm-hmm.
Yeah. What else did people come up with? John, I think you might still be muted. No. Can you type it in the chat for us? Does anyone else have something that feels different from what we've heard so far?
Our group did talk a little bit about adaptations for younger grades, particularly kindergarten. You know, starting out with, instead of maybe sharing it with the whole class, which brings up a large number of kids, you could share it with a group of friends, and then, you know, keep the numbers reasonable and with a one-to-one correspondence, and actually have some granola bars that they could do some sharing with.
Yeah.
I think I represented that well. I don't know. Maybe the rest of the group can chime in a little on that too.
Does anyone in Jim's group want to add to that? So I want to show you just a few examples. So this is an example of student work that Kristen Gray shared with her when she wrote about this particular lesson. So we have this student that thought about it as 5 boxes. Each box has 6 bars, 15 classmates. How many bars does each classmate get? So what do you notice about the choices that the student made? Yeah, so I can see in the chat, Jim said that the numbers are all sort of worked out. So do you think that the student did that on purpose? It's hard to know. We weren't there, right? We don't know if this took 2 minutes for the student to do or if it took 20, but what does it show us about what the student understands?
It shows that he knows or she knows or they know that what information needs to be there in order to be able to do a math problem.
Yeah, definitely.
The student also knew like how to work backwards and get enough candy or granola bars for everyone.
Yeah. So if you have a student who's doing this and making it all work out nicely, like that shows you what that student understands about the relationships between those numbers, that they were able to choose numbers that work out nicely, right? That was purposeful. So I'm going to, let's see. So I want to talk about, first let me show you. So this was the original context. The original context was about 5 boxes, each with 6 granola bars. But it was about how many are there altogether. And then did you multiply or divide? So how would it have been different if we had just given this context out? I'll show you just, for example, while you're thinking of some other pieces of work.
By asking the question, did you multiply or divide, it only gives them 2 ways to do it. Whereas another student might have actually subtracted a bunch of times. But by asking, is it multiplication or division, it limits the students to only being able to solve it that way.
Yeah. I can picture this on a worksheet, like multiplication and division, right? And they're like reading different contexts and just sort of thinking about it in those 2 ways. So in leaving it open, we have some students that even thought about fractions, right? So we have this student here. So we have one student that had 23 left over. We have another student who's looking at leftovers and splitting them up, doing all different kinds of things. So it gives us a much better look into the student's understanding of numbers and relationships that we may not have seen. We even have the student here who thought about percents. So if we return to our questions about access and flexibility and connections to the math practice standards, what are you thinking about with this routine? Now, granted, this routine would be something that would take perhaps longer than the other 2 routines. You could do it in a shorter amount of time if you just did the notice and wonder piece. But what are you thinking about with our themes here?
It sort of feels like students would differentiate for themselves, that if you
Yeah.
just leave it that way, then they will do what they can, and then you could maybe push for one more step.
Yeah, nice. Put this slide up too.
I was thinking that just traditional math books, word problems tend to make some students panic, but if they're doing enough of this work, they'll realize like they are the worksheet creators. They can create those same kind of questions and sort of make sense of how those word problems might have been phrased in the first place for when they do test taking and things later on.
Nice. So, kind of like a peek behind the scenes. Yeah. What connections do you see to the math practice standards? Number one. Yeah. So when we think about students, sometimes as teachers, we find that students will just look at a word problem, pull out the numbers, and then just compute, right? Especially if it says like multiplication with fractions at the top of the page. And so then they're just looking at the numbers and pulling them out and multiplying, right? But because there are no numbers, they really have to make sense of the situation and what's going on, right? So I'm just going to take a few more minutes. We're going to do one more, and then we'll leave a few minutes for questions. So this last routine is called SPLAT. And this is Steve Wyborney's resource, and you can download all of these. They're PowerPoints from his website, and they even come set with like a little introduction at the beginning. So there are 10 different levels to use with different ages. And I just want to show you how they come sort of preset. So this is the level 1, and this is the first one. And it comes with these little question prompts to use. So how many blue shapes do you see? Oops, hold on a sec. Oh no, tech issue, hold on, of course. Okay, how many blue shapes do you see? We see 9, so then the 9 stays there. Now we've got this splat that's covering some of them up. And that's sort of the premise of this resource. And then how many are under the splat and how do you know? So again, this is level 1. And they're thinking about different ways that they can share their thinking, or that they could reason about how many shapes are under the splat. And then you can reveal it. And so again, those prompts are there at the beginning, but then you can go through and the others don't have those prompts. But for our sake and what we're interested in, I'm going to skip ahead. So this is 7. So in this picture, we have the splats already covering some of the dots, and we don't know how many they're covering. But we do know that there are, that some of the splats are red and some are yellow, and that because there are 2 reds, then what's under the red is the same. So what's under the top red splat is the same amount as what's under the bottom red splat, and that's different than what's under the yellow. So first, think about what could the total number be? So you can go ahead and just share out. What could the total be?
$15.
8.
So could someone who just shared one of those numbers say how you got that number?
I did it if the reds were 5, so 5 and 5, and the yellow would be 3. And then one more would be 14.
Okay, nice. So then we can move ahead. So we could spend some time and linger there. We could move ahead and say, we know the total is 14. And then think about the different possible combinations for what could be under the red and what could be under the yellow. So for time's sake, I would have you chat with someone about what you're thinking and different possible combinations and what you notice about the patterns. But for time's sake, can we just hear one possible? Or actually, let's hear two different ones. So what could the combinations be? 5, 5, 3. 6 under red, 1 under yellow. Yeah, go ahead. 3, 3, 7, 4, 4, 5. So I want to show you one more level time just to show you how this idea grows. So we know the total is 18. Now in this case, instead of the dots being just single blue dots, they are worth a value. So we have a 2 and we have a 3. And because we can see the 2 and see the 3, then we know that all of the other dots are also either 2s or 3s. So in this case, we only have 2s and 3s. We know that it makes 18. And because the blue and the green are different, then we know that what's under the blue and what's under the green are also different. So what are some of the possible combinations here? So for the sake of capturing it on the recording, could someone share what they're thinking for a possibility in this case?
I could be wrong, but it's 2 3s and 6 2s. Is that right?
2 3s under the blue. Is that what you're saying?
Yeah, I think I'm wrong. I'm gonna back it up because I'm not sure. I think I missed a detail. I was just thinking for a combination of 18.
Okay.
Like if I have 2 3s, that's 6. So then I need 12 more to make 18.
Okay. So if we see 1 2 already and 1 3 already, then what could be under the blue and what could be under the green?
Gotcha.
So these are actually really neat. If we had more time, we could work on the different combinations. We could make tables and really neat patterns emerge and some really neat mathematical ideas come to the surface. But we are just about out of time. So I just want to quickly debrief SPLAT a little bit. So if we go back to our 3 questions, let's think about access, flexibility, and then the connections to the math practice standards. So what are you thinking about for this activity?
In terms of access, when it allows certain ones allow students to have more flexibility with their answers. There's more than one possibility.
Yeah, nice.
At a secondary level, I wondered if you could ask kids to come up with an expression. You know, in that last one, you could have one you know, the red is X and the other one is 13 minus X.
Mm-hmm. Nice.
Because there's so many different answers, you need to really justify your answer, and you can't just compare answers. You can't say, oh, I got 30, oh, I got 32 at 30 as well, and then say, ah, yes, we have the same thing. You have to say, I got 42 and here's why, and you have to actually check the other person's work.
Yeah, nice. And as far as the PowerPoints with this resource, you do get to a point where it reveals what's under the SPLATs. So it could possibly have one answer, but I agree with what you're saying. Like we don't even have to, we could show that part of the slide, or we don't even have to show that part of the slide, depending on how we want to use it. So does anybody have any questions about any of these ideas that we've talked about tonight? Bev, I don't know, do you want them to just ask by unmuting their mic, or do you want them to submit them?
I think this has been such an interactive session. It just makes sense for them to ask you directly, if that's okay.
Yeah, that's fine.
I guess one of the questions I have is sort of, how often do you recommend using these kind of routines? You know, so how often does one actually do this? I so often feel that people do less interactive things because everyone's chasing after MCAS or some other standardized thing, and we feel so stressed about that. Yet this is kind of where the deeper learning really happens.
Yeah. Yeah, that's a really great point. So I think for that case, it's really nice to fit into some kind of routine like this that hopefully is related to what you're doing in your math lesson that day, every day. And it could be just 5 minutes. It could be 5 minutes at the beginning of your lesson, or it could be 5 minutes when you're in between, you're in a transition, or it could be like, you know, maybe you are coming back from an assembly and you have an awkward block of time. Like, one of my favorite parts of all of these routines is that they also have this time flexibility. So you can do a which one doesn't belong in 5 minutes, or even under 5 minutes with your students, or you could really spend 20 minutes unpacking it. And all of these have that flexibility. Like, you could spend a whole lesson on that numberless word problem, or you could just put up a numberless context and just do a notice and wonder and thinking about that. So I recommend frequently using these. You don't have to use the same one. In fact, I wouldn't recommend using the same one every day. But like I said, depending on your goals of that lesson, thinking about what kind of, you could think of it as like a warm up, what kind of these routines would best sort of fit with your mathematical goals.
So I have a quick question. Because in kindergarten, it's the opposite. Like, it's not that it's hard to make it quick. Like, once that conversation gets going, everybody wants a turn. So how would you then keep it quick without squashing people's spirits?
Yeah, that's a great point. So lots of times when you do these activities, everyone wants to share, right? So in kindergarten, even in my 4th grade classroom, like, they all want to share. They all want to say what their estimate is and why. And so I think about just different ways. So I've seen people use sticky notes where they write on a sticky note, and then we sort of put them all up on the board and maybe organize them so they have their voice heard that way. Or sometimes, like, I'll do that popcorn. I don't know if you're familiar with popcorn, where everybody just blurts out their number, and you only get to blurt once, but often we get the popcorn kernels that pop more than once. But just thinking about other ways, or doing a quick turn and talk, so they do still get to share their ideas, even if it's not to the whole class. Because I agree, you definitely don't have time to hear 20 kids share their reasoning. Yeah, that's a good point.
Great. Sarah, thank you so much for such an interactive session. And Danielle, welcome aboard. And we look forward to seeing you. Is it June the 3rd? I think we decided that you would come on. So we're trying hard to not only have the humanities, but have a couple with mathematics. And Danielle will be coming on and doing some science and technology with us on June the 3rd. I'd specifically like to thank all of our outside guests that arrived today, our participants, and it's some of our elementary education students in the MAT program. Nice to see you all there. We will be, Lauren will be making a copy of this, a recording of this particular session, and either on Monday or Tuesday, you'll all receive an email with Sarah's slides as well as the recorded session, so you can look at it again. Sarah, thank you so much, and everyone have a great week.
Yeah, thank you, everyone.
Thank you.
Okay, bye-bye.
Thank you. Bye.